the next section of the worksheet, we're really going to be moving between what I call three worlds. We're going to be using the old z-score formula that we used on test 1. That formula was z equals the x value of interest minus the mean divided by the standard deviation. Basically, by being given raw scores, we're going to first need to translate them to z-scores using this formula. Then once we've translated them to z-scores, we're going to need to use the table to convert them to probabilities. So we're moving from raw scores to z-scores to probabilities. For this first question, I start out by doing formula z equals the x value of interest, 7.2, minus the given mean, 5, divided by the given standard deviation, 2. When I put this into my calculator, I want to make sure that I'm doing the subtraction on top first. So 7.2 minus 5. After getting that answer, I want to divide by 2. So it's fine if you put it in with parentheses like this, all as one step. If you can't put in parentheses on the type of calculator you're using, do the top first, divide by 2 afterwards. When I put this in, I got 1.1 on my calculator. I need to know that really means 1.10 if I go to 2 decimal places. Again, the reason we're going to 2 decimal places is in order to use this chart. I'm going to go to the positive side. On the positive side of the table, I read down 1.10 has a p-value of p equals 0.8643. That 0.8643 is the correct answer to the question because it was a less than question. Remember, the table values in the table always mean to the left or less than. So this is the correct answer to number 5 on the class worksheet. When I go to set up number 6, again, z equals the given x value of interest minus the mean divided by the standard deviation. When I do it this time, I get a z-score of -2, which I know to call -2.00. I look on the negative side, the side with the graph at the top. The negative side, 2.0, has a p-value of 0.0228. Had this been a less than question, I could stop right there and that would be my answer. Because it's a greater than question, I have one additional step, which is I need to do 1 minus the table value. If I do 1 minus 0.0228, that's going to give me 0.9772, which is the correct answer to this question. When I get to question number 7 on the sheet, there's 2 different x values that are going to be used to answer between questions. Because there's 2 different x values, there's also going to be 2 different versions of the z-score formula that I need to use. The first time, z equals the first x value, 0.48, minus the mean, 0.5, divided by the standard deviation, 0.012. The second time, it's going to be z equals 0.49 minus 0.5 over the standard deviation, 0.012. So again, I'm going to put them both into my calculator to get the proper z-scores. For the first one, 0.48 minus 0.5 divided by 0.012, that gives me a z-score of -1.67. For the second one, where I do 0.49, it gives me a z-score of -0.83. Now that I have my 2 z-scores, I need to look up their associated p-values. For -1.67, I get a p-value of 0.0475. P equals 0.0475. When I do it for -0.83, I get a p-value of 0.2033. P equals 0.2033. For a between question, I take the larger p-value minus the smaller p-value. Larger p-value, 0.2033, minus smaller p-value, 0.0475. When I put this into my calculator, 0.2033 minus 0.0475 gives me an answer of 0.1558, which is the correct answer to this question on the sheet. The 8th question I set up, it's a less than, z equals 41 minus 50 over 7. When I put it in the calculator, parentheses, 41 minus 50 divided by 7 gives me negative 1.285. Because I'm rounding to 2 decimal places, 1.285 becomes 1.29. I will note that Cengage uses technology that might be a little more advanced than our table. So even though I'm asking you to do it from the table because I can't ensure that everybody has this level of calculator, there might be times where you're doing everything right and the answer in Cengage comes up wrong. That's really just because we only have a table that goes to 2 decimals. If you think you're doing everything right and it's still marking wrong, make sure that you're using the Ask Your Teacher feature. If I see it's just a rounding error, I'll tell you what the correct answer should be in Cengage. If we're doing this in person, it's always fine. If you round it, you'll get the answer that I'm going to get on my answer sheet for any test or any formal grading. That said, you do have to use proper rounding. So if you get negative 1.285, you need to know that goes to negative 1.29. When I look up negative 1.29 in my table, I get a p-value of p equals 0.0985. I can stop there because it was a less than question. For number 9, I start with my z-score, 111 minus 100 divided by 19. Again, I need to put it into my calculator so that I can figure out what z-score to look up. 111 minus 100 divided by 19 gives me 0.5789, which I'm going to call 0.58. Now that I have the z-score, I go to my table. I make sure I'm on the positive side. 0.58 points me to 0.7190. If this had been less than, I could stop there. Because it's a greater than question, I do 1 minus that 0.7190. That's how I get a final answer of 0.2810. Final question on this side of the classwork is another between question. So it's going to require me to do 2 different z-scores. The first one is 3.8 minus 4 over 6. The second one is 3.85 minus 4 over 6. So again, I'm going to put each of these into the calculator to get the associated z-score. When I do 3.8 minus 4 divided by 6, that gives me a z-score of negative 0.03. When I do it now for 3.85, I get a z-score of negative 0.025, which is also 0.3. Not ideal. I'm not sure this is a great question, to be honest. Let me see if I did anything wrong. So give me 1 second. I'm just going to see if maybe I put it in wrong. Yeah, I did. The actual sigma is supposed to be 0.6, so I copied these wrong. That's going to move everything over 1 decimal place. So this one that was 0.33 is going to be like that. This one that was 0.25 is going to look like that. Apologies. Now that I've got the right things written, I can look up the correct p-values for those z-scores. When I go to negative 0.33, I get a p-value of p equals 0.3707. When I go to negative 0.25, I get a p-value of p equals 0.4013. Final step, take the larger p-value, 0.4013, subtract the larger p-value, 0.3707. When I put that into my calculator, I should get 0.0303.